Okay, so we're going to do part of the Solving Polynomials test study guide. Students are taking the test on Thursday and Friday this week. This is number 2. What I'm doing here is dividing by a monomial. So I just do each of the terms in the numerator and divide by that 2x squared. So I'm going to get as an answer 5x to the second plus 3x minus 1. All right, moving on. Number 3, it says find the quotient of x squared minus 7x plus 12 and x minus 4. So what you really should do is write it as a fraction first. This is dividing by a binomial. So when you divide by a binomial, we are going to factor the numerator, and this is regular factoring. The combination is -4, -3. If you notice, my numerator has an x minus 4 and my denominator has an x minus 4, so I can just cancel those. So the answer to this problem is just x minus 3. Moving on, I'm not going to do every single problem. I'm going to try to hit one of every type though. Number 5 says x plus 2 times x minus 7 equals 0. So when I get to this point, I just set my factors equal to 0. So I do x plus 2 equal to 0, x minus 7 equal to 0, subtract 2, and I get x equals -2. This is going to be add 7, add 7. So my solutions for this quadratic equation are -2 and 7. Number 9, talking about what the factors would be. So it says that your zeros, or your answers, or your solutions, are x equals 2 and x equals -8. So what I want you to do in this type of problem is to basically work backwards. So you're going to bring the 2 to the other side. So to do that, you would subtract 2 from both sides, and then getting x minus 2 equal to 0. In this one, to bring the 8 over the -8, you would add 8 and add 8, and then you get x plus 8 equal to 0. So your two factors would be x minus 2 and x plus 8. If you notice, the sign of this guy is always going to be the opposite of the sign of that. Let's do number 12. It says that my factors are, it says that my zeros are 2/3 and -1/9. So just to put this guy in, so that you know what the factor is, you would multiply by 3. Multiply by 3, that would cancel this, so then you have 3x equals 2, and you want to bring the 2 over, so you subtract 2 and subtract 2, and then you get 3x minus 2 equal to 0. So your first factor would be 3x minus 2. Again, I'm going to multiply by 9, and I get 9x equals -1. I want to bring the -1 over, so I add 1 and add 1, and then I get 9x plus 1 equals 0. So this guy, the factors would be 3x minus 2 and 9x plus 1. Number 14 says x squared minus 225 equals 0. So you should recognize first that this is a quadratic. Second of all, both of these terms are perfect squares. So we can jump right into what's called the difference of two perfect squares factoring. And I know that there's no GCF. What two numbers multiply together, what number multiplies by itself gets you that, and it is 15. So we write positive 15 and -15. When I get to this point, I'm going to set both of my factors equal to 0 like I always do. And then I solve them both. I would subtract 15 here, subtract 15, and get x equals -15, and then add 15, and I get x equals positive 15. For 17, I'll do that one. 17 says x squared plus 16 equals 52. Now, one very important thing to know about solving a quadratic, if you're going to do it by factoring or by the quadratic formula, is that it needs to be equal to 0. In this case, it is not. So I'm going to bring 52 over. So to do that, I would subtract 52, subtract 52. And then I get x squared minus 36 equals 0. So if you notice, you can do the difference of two perfect squares here. So this would be x plus 6 times x minus 6 equal to 0. And then from this point, you set both of your factors equal to 0, and then you solve them both individually. This would give you x equals -6, and Moving on to the next one on the back. Number 18, it says to solve this using the quadratic formula, x squared minus 9x plus 4 equals 0. My assistant over here needs to have a calculator ready when I ask them to do this. So, the quadratic formula is the opposite of b, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the first thing that I do, guys, is I'm going to designate what my a, my b, and my c are. My a is 1, my b is -9, and my c is 4. A couple of thoughts here. First of all, it has to be equal to 0. I need to be in what's called descending order of power, which it is, x squared, x constant. And I also really prefer for my leading coefficient to be positive. Now that's really only important when you're factoring, but it's also just good practice to kind of have that guy be positive. All right, so here we go. So x equals the opposite of b, which is the opposite of -9, which is 9 plus or minus the square root of b squared. So since 9 is negative, I want to put it in parentheses. Minus 4 times my a, which is 1, times my c, which is 4, all over 2 times my a value, which is 1. So this is going to be x equals 9 plus or minus the square root of. Now, -9 squared is 81. -4 times 1 is -4. -4 times 4 is -16. So 81 minus 16 is going to give us 66. That's wrong. 65. Over 2 times 1, which is 2. So I need my assistants to do the square root of 65. So it's going to be x equals 9 plus or minus, round that to the nearest tenth. 8.1 over 2. So from this, when you get here, there's nothing more to do unless I separate the two problems. So now I'm going to separate into x equals 9 plus 8.1 over 2 and x equals 9 minus 8.1 over 2. 9 plus 8.1 is 17.1, and then 17.1 divided by 2 is 9 minus 8.1 is 0.9, and then 0.9 divided by 2 is 0.45. So my two, you can call these solutions, you can call these zeros, you can call these roots, would be 8.55 and 0.45. So that's how you use the quadratic formula. The bottom there, let's do a couple of these. This one says 2x squared minus 6x equal to 0. There's a GCF here, and the GCF would be 2x. So you would factor out a 2x and be left with x minus 3. There's nothing more to factor, so I'm going to set both of my factors equal to 0. So I do 2x equals 0 and x minus 3 equal to 0. Solving this guy, I divide by 2, divide by 2, and I get x equals 0. This guy, I add 3, and get x equals 3. So my two solutions would be 0 and 3. Let's do 22. That one looks pretty good. 22 says 5x squared equals 30x. So again, I always want it to be equal to 0, so I'm going to bring this over. Now these are not like terms, so I cannot combine them, so I write them next to each other. So 5x squared minus 30x equals 0. Again, there's a GCF, so I'm going to factor out 5x and be left with x minus 6. You set both of them equal to 0, so your solutions would be x equals 0 and x equals 6. Let's do 26 together. 26 says x squared plus 6x minus 4 equals negative 10x minus 68. So I know this is quadratic because of the x squared, and I always want my leading coefficient to be positive, so I'm going to bring these two terms to the left-hand side. So I add 10x, so I get x squared plus 16x, and then I'm going to add 68, and get plus 64 equals 0. And then the factoring here is going to be pretty straightforward. X plus 8 times x plus 8. And then you set both of your factors equal to 0 like we always do. And if you notice in this case, my factors are identical, so you're actually going to produce the same solution twice, which is called a double root, which means that if you were to graph this thing, this graph will not be exact, but I know that this is going to cross. It essentially would cross the x-axis at -8, and it comes down, basically goes, touches that x-axis.